Hi, this recording is set up to go over lesson 4.6 in Delta Math on graph stories. Start by titling your notes, Delta Math 4.6 graph stories. That should be written at the top of your notes before you start watching the rest of this lesson. A couple things to keep in mind. Word problems can be solved multiple ways. So yes, in this lesson, I am going to show you one way. I'm going to show you how I would go about solving this problem. That does not mean that that is the only way that you could solve each of these problems. We are really looking into our way of thinking, okay? And we all think at different ways. Our thinking is different. Mrs. Schneers and I were just talking about what we're going to do for this lesson. It is about, and she's approaching things one way, I'm approaching things a different way. So that is problem solving. All right, so let's take a look at an example. So this example is specifically going to go with Delta Math 4.6, number 1. Okay. You do not have to have the written portion, the Word document printed for this one, but I do encourage it because you can mark up the problem and it will really help you work through it. Right. In this problem, I first want you to read the problem to yourself, pause the video, and once you're finished reading it yourself, unpause. Okay, so now that you've unpaused it, we're going to break this problem down. And that's the way I would do every word problem. I'd first read through the entire scenario, then I would come back and break it down line by line, word by word to help me understand it. So if I look, Nathan left his house at time 0. So on a graph, time 0 is going to be at 0, 0. That's when he left his house. Okay, and he drove to the store, which is 10 blocks away at a speed of 5 blocks per minute. So I'm going to take this information and I am going to change the color of the text so that I can really focus in on what it means. 10 blocks away at 5 blocks per minute. So if I'm thinking that through, that is a rate, okay? You're going at a rate of 10 blocks per minute, okay? So look at yours. I would start by thinking, okay, I start here, I start at 0, 0, and I'm going to travel 5 blocks per minute, and I'm going 10 blocks away. So from my base to 10 blocks is up here, okay? But I do that in order to get there, I'm going 5 blocks a minute. So the first minute, so going over along my x-axis, I would go up 5 blocks. Then my second minute, I would go up to the 10, and I could drop a point there at 2:10. So that shows the rate of travel. Okay, the next section says, then he stopped and went into the store for 6 minutes. Okay, so I'm going to highlight that because he stopped and went into the store for 6 minutes. And I'm going to do that one green. So what's that mean? Okay, that means he's in the store and he stops for 6 minutes. Notice along the x-axis, that is the time elapsed in minutes. So he's going to stay put. That means he's not rising or falling at all on a graph. But over time, he's moving. Time is moving, but his location is not. So I'm going to take this, I'm going to connect it to the orange dot. Then I'm going to go over 6 minutes. Go over 1, 2, 3, 4, 5, 6. So when 6 minutes is elapsed, when 6 minutes has passed, it's now over to a total of 8 minutes, or at position 8:10 on the graph. From there, he drove in the same direction at a speed of 3 blocks per minute until he got to the bank, which is 6 blocks away from the store. Okay, so that's a lot of information there. 6 blocks, he goes at a speed of 3 blocks per minute. Three blocks per minute until he got to the bank, which is 6 blocks from the store. Oh, maybe we should have labeled where the store was. Okay, so come back, reread. The store was at location 210 on our graph. And says that the bank is 6 blocks from that. Okay, so 6 blocks. So if I am at here, 6 blocks is going to be at 16. So I know I'm going to end up around point 16 on my blocks. So I'm going from block 10 to block 16, which is 6 blocks away. But time is passing also. And it said he's going 3 blocks per minute. So I know that I need to get from my green block up to 16, but I'm going over time, and I can only travel 3 blocks a minute. So if I go over 1 minute and I go up 1, 2, 3 minutes, that's 1 minute. And then I go over another minute and can go up 3 more blocks, which that will put you at 16. So really breaking this down and going through it will take you step by step. Then he stopped at the bank for 7 minutes. Okay, so here's another piece of information. Lots of information here. So stopped for 7 minutes. What's that slope going to look like? So we've got a lot of slope and rate of change built in here. That slope is going to stay flat. It's a 0 slope because he stopped for 7 minutes. So if we are at minute 10, 7 minutes is going to be at minute 17. So notice on the graph that that time is above minute 17. Then we go on to the next phase. Then he stopped at home. Then he drove home at a speed of 2 blocks every minute. So then he's going home. Okay, what's that look like? I'm going to change that to red. He's going home. Where is home? You have to think back to where is home? Oh, home is going to be at block 0. Okay, so he's not going to need to come back to the starting point. We're just trying to get him to go home. So we need to get him to come down here to 0. But it only goes at a speed of 2 blocks every minute. So every minute our rate goes down 2 over 1, down 2 over 1, down 2 over 1. So if you count those out, down 2 over 1 takes us down to minute 25. Okay. Each one of these positions on the graph, we could have done it several different ways. We could have looked at making a rate where we could have done distance over time, okay, x over y. You could have found the rate of change, or you can reason through each one of these. It all works. So each one of these coordinates could have been labeled. We can also look at the feedback that Delta Math produces. They used in the feedback also how to find this given distance and speed. So from the house to the store, which was our orange, distance was 10 blocks, speed was 5 blocks per minute. So it would have taken 2 minutes to go 10 blocks. Okay, leading us from 0, 0, take 2 minutes to travel 10 blocks, ended at 2:10. And then he stayed at the store for 6 minutes. So think about you started at 2:10, takes 6 minutes. So then your minutes are increasing by 6. So we went from our X value that was minutes of 2, increased it by 6 to 8. So then you're at location 8, 10. So you could break those coordinates down by X's and Y's as well. And then to get from the store to the bank, distance and speed. Okay, so distance was 6 blocks, speed was 3 blocks per minute. So how are you going to do that? Okay, you're taking 6 blocks at 3 blocks per minute as your rate. So that takes you 2 minutes. So think about what's increasing. You have your X's that are your minutes, and it takes 2 minutes to travel 6 blocks. So 2 minutes We figured out that it took 2 minutes. You can increase that x value to 10. That's how we got that location. So once again, this is just a different way that you could have gone about solving this problem. To get from the bank, so we stayed at the bank for 7 minutes. So the minutes were the y value on your graph. So you could have specifically looked at coordinates to plot your points too. 7 minutes. Oh, sorry. Takes 7 minutes. Location wasn't changing. Minutes was on the x-axis. We increased that by 7. So we got to 1716. That's how we're getting those locations. Then if we also calculate from the bank back home, we knew that the distance was 16 blocks at a speed of 2 blocks per minute. So if you're going 16 blocks and 2 blocks per minute, that gets it down to a rate of 8 minutes. Okay, so think about minutes were on your x-axis. So there was your minutes you started at 17 minutes, increased 8 minutes to get back home, which is why you landed at 25. Okay. So just one more way of going about solving this. Let's look at another example. This one is number 3 in Delta Math lesson 4.6. So take a second, read through that problem first, pause, and then press play. All right, now that you have worked through reading it first to yourself once, let's break this problem down because we need to create a graph showing the inches of snow on the ground over time. Notice the graph is labeled. Time is your x value, so it's along the x-axis, and snow on the ground in inches is your y value, okay, along your y-axis. Okay, so we've got your time compared to your snow on the ground. So let's break down this problem. During a snowstorm, Josiah tracked the amount of snow on the ground. When the storm began, there were 2 inches of snow on the ground. Every time I see numbers, I want to really look at that. I look at it and I think, oh, what's that mean? There are 2 inches of snow on the ground. That means that when I'm starting my graph, I am starting off at 2 on the inches, okay? So I'm starting off here at the 2. Then, for the first 4 hours, the snow fell at a constant rate of 1 inch per hour. Okay, so for the first 4 hours, so that's our first rate of change, the snow fell at a constant rate of 1 inch per hour. So over the course of 4 hours, so the first hour, so you're starting at 2 inches of snow, and then the first hour, you're gaining 2 inches. The second hour, you're gaining 2 more inches. The third hour, you're gaining 2 more inches. The fourth hour, you're gaining 2 more inches. So looking at that, you would end up. So I made a mistake on working through that calculation. I was doing 2 inches per hour, but I see over here in my problem, it actually tells me that I'm going at 1 inch per hour. So where should that slope have been? If it was only 1 inch per hour, so 1 hour, 4 hours at 1 inch per hour grows 4 inches of snow. So then the graph is going to be over, starts at 2 inches, gains 4 more inches over 2 hours, over 4 hours. So over 4 hours goes 1 inch per hour, so that's 4 inches. So sometimes, as you see, I'm kind of muddling through this. I think it might have been easier for me to write down a rate. 4 hours over 1 inch per hour. So that means my time is going over 4 hours and my inches are going to go up 4 inches. So then take a look at the next section. The storm then stopped for 2 hours. So what happens to the slope if it stops for 2 hours? The